Hello, today we are going to look at two-way Anova. So I kind of wrote some of this out beforehand this time in hopes that it would be more clear and better, nicer drawings for most of that material. So what I've drawn here is a representation of what we covered previously, which was the one-way Anova, which is what we call the omnibus test, which is the null hypothesis here is that essentially all these means are the same. And in this case, I've given you an example of a significant where p is less than 0.05. It probably looks like right here, this mean looks like it's a little bigger. That's probably the big difference, but it could be any one of the means or several of them together contributing to make a significant difference. You would examine the graph or do what we call post hoc test to look to see which precise means are different than which others. But I want to go forward and look at an experiment. And I'm going to open this so you can read these things one at a time. Consider an experiment where you want to examine the effect of nitrogen and phosphorus on plant biomass, or growth. In this example, you're looking to increase plant growth with these two fertilizers, but you want to know how much of each to use. You build them both into the same experiment, and it looks like this. So this is a classic sort of experiment where we might use analysis of variance in what we call a two-way Anova. And where our first treatment level is here on the nitrogen level. We have low and high nitrogen, and we have a second level of treatments here we call phosphorus, which is at high and low phosphorus. So we have two treatments, each at two levels. This design is referred to as fully crossed because every level of phosphorus is tested at every level of nitrogen and vice versa. So that means that it's a very easy to interpret. And let's look at mechanically or process-wise what's happening in a biological context. So I'm going to give you a couple of different cases here. I should point out that we have 10 samples in each category and 2 treatments. I've mentioned those. Now we're trying to figure out how these fertilizers might affect plants. Case 1, it could be that nitrogen helps plants grow faster. So whenever nitrogen is added, it boosts biomass by about 20%. Phosphorus also might help plants grow faster. So whenever phosphorus is added, it boosts plant biomass also by 20%. When both are added, it increases by 40%. So in this model, we would see that basically if this is happening, if you buy and add nitrogen, you'll get increased growth. If you add phosphorus, you get increased growth. If you add both, you get double the increased growth. So that would be sort of an additive effect such that the two treatments are working independently. And so the effect of one is very independent of the other, all right? But both have an effect. In case 2, the biological process might be different. It might be that adding nitrogen only increases biomass if phosphorus is added as well. Now, if that is the biological process, then there won't be any effect on biomass if you don't add both things together. So this could actually be very common in ecology. And the same might be true in the other direction, right? That you might not get an effect of phosphorus if you don't also add nitrogen. So when both are added, you get a 40% increase, and I'm sort of making up that data. And let's take a look at what that would look like. In case 1, where the two effects are independent of each other, we are seeing an increase, and I'll try to write this on here in blue. You're seeing a little increase here for high nitrogen with no phosphorus, and an increase with just phosphorus but no nitrogen in that case. And when you get high nitrogen, high phosphorus both, you get this really, really big increase. All right. In case 2, remember, neither of these alone are going to have an effect. So high nitrogen and high phosphorus down here are not going to have any effect at all because they don't have the other one added. However, we're going to get a great big effect over here when both nitrogen and phosphorus are added together. So in this case, you actually have a biological process occurring that creates this statistical pattern, right? Let's take a look again at how that might look in the data. So in this case, I'm going to bring over this data from over here, and I'm going to look at case 1, and we're going to say, okay, what does case 1 look like? So I redraw my data set, and I put my 10 samples in each square. And this time, though, I'm going to highlight on here that I'm going to look at how big will the means be. We know that low and low will make the smallest. We'll get a little bit of growth, 20% growth, out of just high nitrogen, and a little bit out of just high phosphorus, and a lot out of high nitrogen and phosphorus, okay? So this should reflect, this should be, this should look like small, medium, medium, large, right? If you were to look at those, and on the graph up there. And then when we test that, the way Anova would test that is we would first look at the main effect of nitrogen. And to look at the main effect of nitrogen, we would essentially pool over the both high and low treatments of phosphorus and compare low versus high nitrogen. And notice we're pooling all the data, and you're getting this data down here. Whoops. X bar nitrogen low, X bar nitrogen high. So those are two means. But you can tell when you look at those means, as I've drawn in this graph over here, you can tell that the low nitrogen will be the addition of a small and a medium together, right? And the high nitrogen will be a medium and a large together. So of these two, you can guess which is going to be bigger, right? The medium and large will have a higher mean than the small and the medium. So we get this graph. Again, I'll highlight where I'm going through here. This graph here, where we get an effect. You can see that the high nitrogen has a strong effect compared to low nitrogen. This is called the main effect of the treatment. In this case, it's the main effect of the nitrogen treatment, right? If the effect of nitrogen levels is significant, that is, it is significant if the p-value for the main effect is less than 0.05. We can also test the main effect of phosphorus. And in that case, we would be pooling across both levels of nitrogen and both levels of nitrogen and looking at low phosphorus and high nitrogen. And in that case, you would also have together, you would see that in the top, the low nitrogen level, you have a small and a medium. And then you would have, again, a medium and a large over here in the high category. So again, you would get bars that look very similar to the other main effect. And again, the main effect of phosphorus would be the effect of nitrogen levels would be significant if the p is less than 0.05. So we can test the main effects. Now, what we haven't really accounted for, though, is we've gone back and we know that in each of these four categories from our original graph here, we know that these four categories have different responses. So let's take a look at what else we can look at. And the third term here, in what we call our Anova model, is called the N by P interaction. Now, it's not actually a multiplication. It's just N by P means N interacting with P. It's the interaction term, or the cross with P term. So the interaction of nitrogen phosphorus treatments, if the nitrogen by phosphorus interaction is significant, and that is that P is less than 0.05, then the effect of the nitrogen levels will depend on the phosphorus levels. Very important language that I'm using. The word depend is really important. If the interaction is not significant, meaning that P is greater than 0.05, then the effect of nitrogen levels is independent of phosphorus levels. So if it's not significant, now what exactly does that mean, dependent and independent? An alternate way of looking at this is to say, is the effect of nitrogen consistent across phosphorus levels? And if it is consistent, right, if this is true, this alternate, then what we'll see is that there's no significant interaction effect. To look at this, we can draw a graph. And my favorite graph for this is the two lines. So for each treatment, I'm going to draw a separate line for each nitrogen treatment, and I'm going to put the phosphorus on the x-axis at low and high. And so I'm able to put these dots in here because I know that, for example, I guess the best way is to look at this is you know that you have a low value and we know that the highest value is both high phosphorus and high nitrogen. So that'll be this one up here. That's the highest value. And we know that the medium value of some phosphorus and some nitrogen, these two should be at about the same height, which they're not quite at the same height in my graph. And we know the lowest value should be low nitrogen, low phosphorus, which should be down here. Now we look at these two lines. And again, a little bit tricky to make this graph, so something to think about when you put it together, a separate line for each treatment level of one variable. And then when the lines are parallel, the effect of nitrogen is consistent at all levels of phosphorus. So I'm really looking at sort of this distance here and this distance here. And if that distance is consistent between the two, that means that the effect of nitrogen is consistent across different levels of phosphorus. And that would mean there is no significant interaction. So oftentimes that's what people like to see because it makes it very easy to interpret the main effect. So I go back to look at the main effect, and I could say the main effect of nitrogen is significant. If you add nitrogen, it will increase growth, and if you add phosphorus, it will increase growth. And the two do not interact. Let's look at the other alternative where we might have a significant interaction. And that might look like this other model that we talked about, where the plants actually don't experience increased growth if you don't apply both nitrogen and phosphorus, okay? So that looks like this case 2 graph here, and then we're going to draw that out like this. The same process applies. We're going to have, in this case though, 3 small plant groups of all the categories that don't have both kinds of fertilizer, and then we're going to have one large group, right? This should correspond to this graph here in case 2, where we have 3 small means and 1 higher mean, right? Now, as we move over and take a look at the graphs, if we look at the main effect of nitrogen in this case, what we would see is that, again, when you add the 2 smalls together here and a small and a large together, you're going to see a main effect of nitrogen. That is, the mean for the low and the mean for the high are going to be different. So this is probably going to be significant at P is going to be less than 0.05. Now, if you look at the main effect of phosphorus, you find the same issue. Again, we're pooling across levels of phosphorus for nitrogen's main effect, and we're pooling across levels of nitrogen for phosphorus's main effect. And as we compare those two means, we'll of course find that, again, you've got those 2 smalls at the top and a small and a large at the bottom there, which means the high phosphorus is going to show a higher mean. And so again, you're going to see a significant main effect, which is going to be with a P of less than 0.05. So then we get to the interaction, though. This is where it gets interesting. If we plot the interaction, it looks something like this. Oh my goodness. When we look at the low category, the easiest way to do this, we know that the high category of both things is the highest dot, and it's high nitrogen, high phosphorus. But we also know that the other 3 values are all the same and they're low. So they're all going to be at the same level here on this side. And so I've put the 2 dots here pretty close together. So they're at the same value. You can see them. So that's low phosphorus and low nitrogen. Either one is low, you get a low biomass, right? Small biomass. And then on the high side, you can have high phosphorus and low nitrogen, and you still get no change, right? And then you see a great big change for high of both. So if we look at these 2 lines, they are clearly not parallel. The distance between here and between here is not the same. And that means that the effect of the nitrogen, high versus low, depends upon which level of phosphorus we're at. Ta-da! And that is called a significant interaction. There are several ways of saying that. I guess I didn't write it in here. I'm going to write it out here now. It says that the effect of nitrogen depends on the level of phosphorus and vice versa. Okay? So that is an interpretation of the interaction. A formal important thing to come away with from the interaction is that the interaction is, if it's significant, that is, the main effect lines are not parallel, then the main effects can only be interpreted in the context of the significant interaction. What that means is when we go back to look at the main effects in this model, and I ask you, Okay, I say there's a main effect of nitrogen. Hooray, the main effect of nitrogen. Does that mean that if I add nitrogen, the plants will grow more? And that's only partly true, right? Because they won't grow more if there isn't any phosphorus present. And that means to interpret the increase in growth due to nitrogen addition, you have to include the statement about the phosphorus. So you can say nitrogen increases the growth rate of plants only when it's added in the presence of phosphorus. And vice versa, phosphorus only increases the growth of plants when it's added in the presence of nitrogen. So that is the magic of the interaction term. So if you need to explain it and you have to say, what is an interaction that is significant? The interaction is the effect of treatment 1 depends upon the level of treatment 2. Or in this case, the effect of nitrogen depends on the level of phosphorus. And it is also can be said, and I underlined all these words because these are very specific words. You should memorize these words just like you should memorize the ones I just said about N depending on level of P. The interaction is significant. Though that is, the main effects lines are not parallel, then the main effects can only be interpreted in the context of the significant interaction. So sometimes we're looking for an interaction because we want to find out the true pattern that's happening in nature. And because as we progress through time and ecology becomes more and more complicated, we're looking for more and more complex patterns. I was at a talk recently and a lecturer was talking about how the public becomes educated about complex issues. And the most important thing that he felt about educating the public was helping them understand that many problems have multifactorial answers. And that is exactly what we're doing here, is recognizing that there is more than one level of process at play here that explains plant growth's response to fertilizers. And so you now have a multifactorial way of looking at how things work. So thank you for taking some time to think about ecological problems.